Cool. Thank you, Julia. Thank you so much for the nice introduction. And hello, everyone. My name is Zain.
My name is Mohammed.
Yeah, and we're here to talk about Git and GitHub and just how to get good at GitHub. And thank you for joining us for a CS50 seminar. I believe this is the second one, and we'll just jump straight in.
Cool. So essentially what we're going to talk about today is Git and GitHub. And the first thing we're going to do is give us some context around what Git is, how it's used, and then we'll get into more sort of specifics. So Git is essentially your superhero in version control. So it is a distributed version control system used to track changes in source code during a software development. And this essentially means it's a platform that allows people to collaborate on code, distribute different versions of that code, and you can do a bunch of stuff with that. So you can track history and revisions, and you can share code with a repository. So distributed version control means that every developer can have a local copy of the repository and the code. And so essentially, Zain and I can be working on a project together, and there's going to be a copy of the code that is accessible by both of us. And then we're each going to have our own local versions of that code so we can edit it differently. And that allows us to collaborate on the project, and there's a few functions around that. So why do we use Git? So there's a few different reasons. I've already told you, like, collaboration is quite useful. It allows you to revert and view different versions of code, and it also gives you a good access to tracking the history of code. So if you accidentally delete or mess something up, but can't remember what you've changed, you can revert to a previous version of your code. So that's quite useful. It can also help you track sort of the evolution of code over time. So if you're developing and building a really big code project, it's quite nice sometimes to have a record of where it's going, when you've changed certain features. And you can even track how those relate to the output of that, so how people have used your platforms and things like that. So it's quite nice to have access to that edit history. So how does Git work? The first step in using Git is to create a repository, or often referred to as a repo, which is your starting point for storing your project code. Oftentimes you can create it empty and then add some code into it. And once you have that repository with your base code that you want all the developers to work on, the developers can clone this repository to create their own local copy, and work on parts of the code themselves, or work on all of the code themselves. Really, once you have a local copy, it's up to you how you want to work on things. But communication is quite important, as you'll see later, because it depends on if you're working on the same or different parts of the code, and whether or not that's going to result in a conflict, which we'll get to as well later.
Yeah, so Mohammed gave us a really great explanation of Git, and I'm here to talk about what GitHub is. And actually, this might be a surprise to you, but we actually already have a GitHub account through CS50, and I'm pretty sure we already set up our GitHub accounts, and running check 50 and submit 50 when we use and submit our presets actually pushes your local work to GitHub. So essentially, GitHub is a web-based platform that provides cloud hosting for Git repositories. So essentially, it allows you to store, manage, and share your code with everybody else. Kind of gives you a collaborative space to be able to, kind of like take what you have locally stored on your computer to share it with anybody else. So features of GitHub include issue tracing, pull requests, project management tools, and so much more. So the reason why we use GitHub is because it's an interactive online platform, and essentially you're not only bounded to what you have stored locally, but essentially you can collaborate on your code with others and kind of embark on large projects. Essentially, GitHub integrates with Git, but it is, in comparison, more visual and has a nice user interface, which makes it very easy for us coders to be able to use it. And as I mentioned, it is great for collaboration. So this includes open source projects, private company projects, or your CS50 final project that you'll be starting very soon. So we did kind of touch upon this, but Git and GitHub are not the same things. Again, Git is a local version control system and all stored locally, whereas GitHub is stored remotely on a cloud hosting platform. So an easy way to think about this is GitHub is a host for Git repositories.
Okay, so now we're going to get into the overall Git workflow, and this is essentially sort of from start to finish what the steps look like for using Git. I'm going to go briefly through these, and then we'll get again more into the specifics of how each of these work. So I've already started this, and essentially you've created your repository, you've put in some stuff, and now you want the local developers to be able to access it. And so the local developers need to pull new changes from the remote repository to their own local versions. There's a bunch of things they can do from there. So you can branch from main to a new branch. And this is, we'll get into this more detailed, but this is essentially if you want to create a separate branch of the code completely. You can implement code and change on your local repository. And once you've made some changes, you can stage those changes to be committed. So this looks like deciding which files to add, deciding which pieces of code that you've changed that you want to make sure are updated into the next part of the code. And once you've done that, you can commit that work and that code. And the last step is to push the commits from your local repository on your computer to the remote repository in GitHub. So essentially, pushing your code is sort of the final step, and pushing your code changes what is stored in the local repository. So you only really want to push code once you're sure that it's the best version or the code that you're going to go forward with, so you don't lose, previous versions that you've had before.
Yeah, and now we'll talk about the terminal and command line. So coders traditionally use the command line and execute commands from the terminal. And if you could see kind of on the side here, we actually have been using the terminal when we use the CS50 code space. And that's where we do all our callings for check 50 and submit 50. And essentially, this terminal is where you'll do all your Git commands, which we'll cover later on. But this code space, the terminal and the code space will be included if you download VS Code on your computer. Also, you can use terminal, especially, like, for example, if you're using a MacBook, you could find terminal on your Spotlight search, and then you could call all Git commands there. So before we learn more about Git, we'll review some of the commands that we've been using in class. So ls is short for list, and essentially once you put that in the terminal, it'll list all the folders and files that is located in the current directory that you're working on. cd stands for change directory. So once you do cd and write the name of some directory, you'll be entering into a directory that you have. You could also do cd ... and that'll basically take you out of the current directory that you're working from and essentially put you into the parent directory. Something that's not on this slide is that you can also just write cd without the dots, and that'll exit you out of any directories, and you can start from scratch. You can also do mkdir, which stands for make directory, and then if you just enter a new directory name, you can create a new directory.
Cool. Just before I get into cloning a repo, one thing I forgot to mention is that when we're looking at terminals and the command line, so this is the terminal from CS50, and we have terminals that you may have used elsewhere, such as in VS Code. Mac has its terminal as well, and just to note that Windows also has access to terminals. Sometimes you may need to download or use different terminals depending on what your project needs. And so this is just something to have a heads up for if you are a Windows developer. Okay, cool. So let's get into cloning a repo. So essentially, you would have seen, if you've used GitHub before, this box on the right-hand side here, where you'll see that you can copy this SSH code. And so you can put into your terminal the command git clone and paste in the SSH link. And this will essentially allow you to clone a repo and be fully connected to it from your local device to whatever is in GitHub, which is your remote version of that code. So essentially then, this is quite useful because once you've done this, you can use all of the following commands that we'll learn about, such as commits, pulls, pushes, and all of those things.
Perfect, and now we'll go over the Git terminal commands. Just note that this is not a fully comprehensive guide, but we'll just be going through some of the more important ones that will probably help you on a project like your CS50 project. So we have git status, and this is one of the most important Git commands to know. It'll tell you which branch you're working on and its relationship to the remote repository. So it'll just tell you how many commits you're ahead or how many commits you're behind, and we'll just talk a little more about commits later on. Git log essentially lists all the commit history of your current branch. So if you remember a couple slides ago, we talked about how Git kind of is like an edit history of your code. And essentially, by saying git log, you essentially return the edit history, and you'll be able to see what the commit history of your current branch that you're working on is. And you can use git branch, and essentially this will list out all the different branches that is located in your local repository. And we'll also be covering exactly what a branch is very soon. So on GitHub, let's just see how this all pieces together. So to see the status of your branch in comparison to the main branch, you can essentially go to the Code tab in the very top, and then you'll then click on the main drop-down menu. And then you'll be listed out different branches that you have on GitHub. And then if you click on the View All Branches afterwards, you'll be able to see all these different branches. And for each of these branches, you'll have where the yellow boxes, it'll tell you how many commits were behind main and how many commits were ahead of main. And essentially main is the main branch that has all the main code in it.
Cool, so let's look at what commits are. So commits record these changes made to your project files. And this is the terminal command git commit -m, and then your message in the terminal to commit your code. I've given an example here. So this is a project I was working on a while ago. And so there was a profile page UI, and once it was complete, the other developer committed this code. And I was working on the get in contact page, but it was still in progress, so I committed a version to save it, but noted in progress. So these commit messages are quite important and are useful for referring to later. They really allow you to tell, what parts of the code you had, and also allow other developers to see what parts of the code you're working on and how far you are. It's also really nice because you can essentially later roll back to a specific commit. So if you know you've saved it or committed it at this point where it was previously working, and you've noted this in a message, then you can easily go back to that piece of code, and it's useful for referring to later. So in terms of git commits then, there's 3 sort of steps in commands. The first is to stage all your changes, and this is the staging step we talked about in the workflow earlier. The staging step, you can git add dot, so this is essentially adding all of the files. Dot just means everything. If you want to add just specific parts and exclude some of them, you can git add and then add these parts manually. So this would be, say, git add and then the name of some specific file that you want to add. Once you've added everything, you can make a commit. So you can commit these staged files. And you can also update the last commit message if you really want to. This is quite useful if you want to change a message to something that's more meaningful to you later. And then again, that's quite helpful to you if you want to refer back to that code.
Yeah, now we'll talk about the different branches and what branches essentially are. So essentially, you can branch the repository you're working on to work on specific features or parts of the code for more complex programs with lots of moving parts. So for example, if you're working on an app, and let's say you want to work on a feature that, for example, just showcases foot traffic, then essentially you can branch your repository and have that one branch work on how to create a code that measures foot traffic. So the way we can do this is we'll use the command git branch and write the name of the branch in the terminal, and essentially that'll allow you to create a new branch. And you could also use the command git checkout along with the name of the branch to begin using the new branch for commits. Yeah, so now again, just going back, same thing, and just these are how the commands that we talked about would be implemented in your code. Something else to mention is that you can also switch to another branch directly from your terminal. You could call git switch and then write the name of your branch, and essentially that'll allow you to switch between the different branches, and from here you'll be able to make changes, commits, pushes on the new branch. We talked about the 3 different commits or commands that we can use, but a shortened version where you can combine all of those is simply the command git checkout -b, and then you can write your new branch name. And essentially, this would create a new branch, and it will allow you to switch immediately into the branch instead of having to create a branch and then manually having to switch into it. So, and also just keep in mind that branch names should not have any special characters except for a dash, the hyphen.
So let's look at git push and pull. These are probably the most used commands once you've started using GitHub. Amongst commits as well. And these are essentially how developers can collaborate on the code, pushing and pulling from the repository to access bits of code and to update pieces of code as well. So we'll first look at push. So once you've edited some code in your local version and you're happy that it works, you can push this code and update the repository. So you use the command git push in your terminal to push it to the repository. And this is fairly straightforward because essentially, so you've committed your code and you've reached that stage in your Git workflow, and now you want to push your code. The important thing to note with pushing your code is that it's going to update whatever branch you're on, and so it's going to change all of the code in there and all of the code that other developers can see. So importantly, you want to make sure that the code that you're pushing is going to be code that is quite good, that is right, and that is better than the previous version. Otherwise, you'll probably have to roll back that code to access the previous version, if that makes sense. And then we've got a couple of commands here that you can use. You can do git status. Again, this is important to check the current branch because you want to make sure that you're committing to the correct branch that you're supposed to be working on. You can use git log to check the commit history. And before you push, you should thoroughly test your code, again, to reiterate that. And then obviously the git push command, which allows you to push all of these new commits and new changes to your remote repository.
Yeah, and before I talk about the pull request, which is the other side of the push, just to clarify, yes, the branches can be accessible to anyone that is in the repository. So the branches is essentially, this is the great part about GitHub, is because it's very collaborative, and so you can create different branches and they will all be accessible by anyone who has access to the repository itself. Moving on to talking about the pull request, so you can, in opposition to the push request, you can pull code to update your local repository to the latest version that is stored in the repository. And essentially, you can collect all the changes that other people have made to the code. And essentially, you can do this by calling the command git pull in your terminal, and essentially be pulling the code from the repository. So again, pushing code basically pushes what you have locally into the cloud-based system, and then pull essentially puts whatever is hosted within GitHub into your local computer. And also just note that it is generally best practice to pull code before you continue editing to avoid any conflicts and just merge conflicts, which we'll also talk about in a couple slides. Let's look at how you would pull from the remote repository and how you would call that in the terminal. So you have the command git fetch, and essentially this will download any changes in the remote repository. And just note that this will not affect any of your files. You can also compare your local repository with the remote repository by using the command git diff master origin / master. You can also check the status of your current branch by just entering git status. And then finally, this is very simple. You can pull your changes and commits from the remote repository by just saying git pull. So that was the git commands you would use to pull, but also you could actually pull directly from the GitHub website itself. So what we can do is, so initially we were on the code tab on the very top, but we can move over to the pull request tab in the GitHub repo page, and then essentially we'll click on the new pull request button that's in green. And this, you'll be taken to this page, and you'll be able to open a new pull request. Just note that it's always good practice to have a brief description of the pull and essentially what you're pulling. And essentially in this description, you'll be talking about what are some of the changes you made, or what are some of the things that you've added into your code, just to be very clear and consistent with your code, and just to make sure that any other collaborators on the repository know what you've changed. So once you enter your description and the title, you're ready to click on Create Pull Request, and you'll be pretty much good to go.
Okay, so now let's look at what merging and conflicts are. So sort of the scenario that leads to a conflict is going to be when I have pulled some code or I have pushed some code, and that's going to have an error in comparison to someone else's. So say, for example, Sane has pushed some code to the repository. I have been working on the same piece of code, and I've made some edits in my own local version, and then I have pulled this code of Sane's that is going to be in direct contrast to the code that I've edited. And this is going to create a conflict because the computer's not going to know which piece of code is better, and so the computer is going to have to ask you to decide that. So this is called a merge conflict, and we've got an example here. So someone had changed in their local repository the color to green, and someone else had changed the color to white in the version of code that they had pushed. And then they had pulled this code, and so now the computer's not sure whether green or white is the correct piece of code to be there, right? And so here you can see the sort of view that the user gets out of this merge conflict. And you'll want to essentially delete a specific part of this to fix this issue. This is not to be confused with branch merging, which is different. And the purpose of branch merging, which I'll explain a bit more on the next slide, is essentially to allow you to merge two branches or join branches once you've worked on different parts of the code. So generally when it comes to software development, oftentimes the good practice to use is to create different branches for different features or different pages of code that you're going to be working on. So suppose that there was two different features and Sane was working on one and I was working on the other. We would have created two different branches to work on these separate features. And at the end of the day, once we'd both finished with our features and done it successfully and we were happy with that code, we'd want to merge these two branches. And they shouldn't have any code that's, in contrast to each other, because all the files are separate because they're two separate features. And that's sort of the hope when you're working on a software development project, to avoid conflicts as much as possible and avoid coders working on the same pieces of code for different features. So these are a few of the commands that you can use. Git status, again, is important to check the current branch that you're on. Git checkout is going to allow you to switch the branch that you want to merge to. And then git merge, and the name of that target branch is going to allow you to merge these two branches. This is also very important to note, is one of these operations that is going to change your code and change all of the stuff you have stored in your repository. So it's generally best practice to make sure with everyone, that their features are completed, that these branches are correct, to do some testing and check if these features work before you merge these branches. In the event that, these branches might have a lot of conflict, that's something to check ahead. But merging is quite important, and hopefully by the end of your project you would have merged all your branches to get one big project that's overall, fully functional and is ready to be deployed.
Yeah, so we actually talked a lot about GitHub and different Git commands, but let's just talk about why all this is useful and why just GitHub and Git is so important to us. First of all, and as we emphasized, collaboration for your projects. GitHub essentially allows multiple developers to work together, and you don't have to be in the same room together, and you don't even have to be on the same local repository together. You can all work on this asynchronously without having to send code back and forth in a complicated manner. Also, with all the different merge commands and everything that we talked about, it's very easy for us to just work independently and be able to push and pull changes so that everyone that's working on the project is updated, and we all have the same updated code. Another thing is we can avoid redundancy and just be clear about the version history that we're working with. So you can create and store previous functional versions of the code and branches to avoid losing code when editing. Remember that Git essentially kind of allows you to look at the whole edit history of the code you had, and just allows you to keep track of the different versions that we've been working on. So you can you have this storage of these previous functional versions of the code, and essentially you will be able to avoid losing any code when you're editing, since code can get messy really quickly. And again, you can avoid rollbacks. So in the event that you accidentally push an incorrect code, let's say, to the cloud repository, you can always roll back to a previous commit so you don't lose all of your hard work. And again, so if you do, let's say, somehow push something and it was a mistake, absolutely no worries at all. There is always a way to retract that and just go back to a previous commit and just revert back to the previous version of the code you had earlier. So essentially, Git and GitHub all combined allows you to be able to really maximize the efficiency of working on a project with just by yourself or with others.
Cool. So this is sort of, I guess, the last part of our seminar, and we will sort of answer some questions after this. But so essentially, these are the steps you'd like to follow, if you immediately want to get started to do this on your own computer. So first, you can install Git. You can check if Git is already installed on your device using git -- version in your terminal. In the event that it isn't, you'll want to go to the Git site. This can be found, this link can just be found by Googling, how do I download Git? And so this install is quite useful. If you have a GitHub account, if you are taking CS50, you likely already do. You'll want to connect the SSH from your GitHub account to Git. You'll want to install VS Code, the app. The CS50 code space does not count. VS Code is sort of setting up your own sort of coding environment for the first time if you haven't done this before. And once you've got all of these things done, you can begin with your first step that we talked about in the beginning, which is to create a repository, to clone it, and to begin your first project.
Yeah, and that's pretty much all we have to talk about Git and GitHub, and thank you so much. If you guys have any questions, we're more than happy to respond to any and just clear up any confusions you might have about Git and GitHub.
Yeah, thank you for having us.